Welcome to Chemistry with
Danielle
and Leah, where we make chemistry a little less scary and a lot more fun.
Today we're diving into 7 big topics, all stuff that sounds complicated.
But we promise by the end of this video, you'll actually get it and see how it actually connects to nursing.
Grab your notes and maybe a snack and let's jump right in.
Okay, the first thing that I'll be talking about, is electromagnetic radiation. Okay, so first up, electromagnetic radiation. Fancy name, right?
Basically, it's just energy traveling in waves like X-rays and microwaves.
Each type has a different wavelength and frequency, and the smaller the wavelength, the higher the energy. Think red light equals chill, violet light equals intense.
An example of an electromagnetic light would be a visible light spectrum. So it would be like, these are the wavelengths, and then it'll go like this. This will be the cooler side, and this will be the light. So think red over here, and purple. Oh, I forgot this. Kill germs and bacteria.
Science is glowing, literally.
All right. Wave and energy equations, the math behind the magic.
There are two you gotta know. C equals
Lambda.
lambda. Nu equals, which means speed of light equals wavelength times frequency. And E equals H/U Nu equals, which means energy equals Planck consistency time frequency.
If that sounds like a mouthful, just remember, more waves, more energy. Simple. So for an example, you have
Okay, so this would be the equation for it.
the equations help us understand the relationship between energy, wavelength, and frequency increase and energy increase tool. So this will be the equation to get the wave and energy equation. This is considered the wave. This will be considered the energy, and then you'll multiply it together to get the total.
Yeah. Chemistry equations might look scary, but they literally explain how a MRI keeps your organs, cameras ready.
So say cheese or say nucleus.
Okay. The next topic I'll be covering quantium numbers. NIMLMS. Okay, now for the quantium numbers. The unlimited address system for electrons.
Right, each electron has a full-on zip code. N equals energy level, I equals shape, ML equals direction, MS equals spin.
It's like saying, hey, I live on energy level 2 in the p orbital neighborhood apartment. ML equals +1 and 1 spin clockwise.
So some examples of quantium numbers would be hydrogen, which is
H.
Hydro, and then it'll be, is it
1s to the first power minus,
it's a minus sign?
yeah, like a slash. Okay, N equals 1. I equals 0. ML equals 0. MS equals plus 1/2. And then you got oxygen.
Or is it 1 and 1/2?
No, it's just one now. This is Cl. What is hydrogen?
Yes, so this will be the quantanium numbers for hydrogen. You have, can y'all see? You have N equals 1, L equals 0, ML equals 0, MS equals plus 1.5. So when you're working as a nurse and your MRI images, just know it all thinks of spinning hydrogen and a little bit of quantanium flour. Now, on to electron configurations, aka how electrons sit in their orbitals.
We feel from the bottom up. Lowest energy first. It's kind of like boarding a plane. Economy feels before first class.
Exactly, except no one's fighting for a window seat. Examples of electron configuration. She's gonna show you guys.
Okay. So we
So this will be the electron configuration of sodium. Each number basically breaks down sodium. And this will be the symbol on the periodic table.
periodic table. Okay, so in nursing, this helps us understand ions, like how Na and Ci combines to make salt, which is in IV fluids.
So yeah, electron configuration equals hydration station.
Okay. Next one we have Lewis dot structures. All right, let's talk about Lewis dot structures. These are basically stick figures drawing for molecules.
Each dot is a balanced electron. And when atoms share dots, that's a bond. When they don't share nicely, it's an ionic bond. You know the drama. So I'm gonna show you guys water, which is H2O.
Of course.
So H2O will literally just do this. You have an H,
A 2.
you have an O, then you have another H, and then you got 2 dots, literally, like this. And that's H2O. Lewis structures show how atoms share and transfer electrons to form bonds. So these are the bonds of H2O.
Okay, so Lewis dots help us see who bonding who's with who. Kind of like chemistry versions of Love Island. Okay.
Except with electrons, not emotional. Next up, VSEPR, valence shell electron pair repulsion theory.
And otherwise, electron pairs are like siblings in the backseat. They stay as far apart as possible.
We'll just put them. Okay. So.
Okay, so this is what it would look like.
So basically saying a VSEPR stands for valence shell electron pair repulsion. It predicts the shape of a nucleus. So basically everything, as we mentioned, it stays far apart. All the H's are far apart from the C.
They're not touching at all.
And they'll make the pyramid shape of a nucleus. Molecule shape actually affects how drugs work. Molecules have to fit perfectly into receptors.
So yeah, chemistry is basically molecules matchmaking.
Last but not least.
Last but not least, chemical numerator.
Name compounds.
Okay, so last one. Chemical, how we name compounds, aka how we name compounds.
It's like chemistry language. Iconic compounds are metal, non-metal, and molecular compounds are two non-metals. For an example, we have
CI.
NaCl.
And this is basically sodium chloride table salt, basically.
Then I'm gonna give y'all another example of one. This one easy. Y'all should know this one.
Yeah.
It's water.
Okay, basically, it's water. Yeah. Dehydration monoxide.
Hydrogen monoxide. Then we're gonna give y'all this one too.
Do y'all another one.
Just y'all. And we got Ca, that's CO.
CO3 at the bottom. Yeah.
And this is calcium carbonate. So it's the Tums, and yes, the acid.
Okay, so the next time someone says chemistry is useless, just remember it literally names your medicines.
Exactly. We're out here deciding drug labels like it's work.
So today we're covering electromagnets, radiation waves, quantum numbers, electrons, configurations, Lewis structures, VSEPR, shapes, and naming compounds.
We hope you learned something and had a little fun with us along the way.
Because chemistry doesn't have to be boring.
It's science. Make it stylish. Thanks for watching Chemistry with Danielle and Leah.
Bye.